As we begin our homework, make sure you have your Exponent notebook, something to write with, and your homework practice sheet. Okay. Let's first turn to the back side of your cover page on your Exponent notebook, where you have your 4 laws of exponents already written down. And let's add the 5th. And the 5th is no powers of quotients. Okay. Then if you'll turn to the next blank page of your Exponent notebook, and if you would label at the top, Unit 1, Day 3, and copy down this learning objective. It states that you will use the division properties of exponents to simplify exponential expressions. Okay, first, let's think about a little vocab word here. The one word I'm really concerned with in this unit, this day, I should say, is the word quotient. Okay? Well, if you guys don't remember what quotient means, remember that it's just the answer to a division problem. So let's write division answer. Okay? Draw yourself a little line after that, separating the vocabulary from an example we're about to do. Okay? Now consider this. Let's say we have a quotient. 3 to the 5th divided by 3 to the 3rd. Okay, well recall, 3 to the 5th just means you're going to multiply 3 times itself 5 times. 3 to the 3rd, down here in the denominator, means you're going to multiply it by itself 3 times. Then you can begin to see that these 3's, through division, will begin to cancel each other out. So that the only thing that's left in the numerator there is 3 times itself twice, or 3 squared. So as you look at the original powers, notice that their bases are the same. They both have a 3. But if you look up at their exponents, if you subtract the 5 and the 3, what you get left over is the 2. This shortcut is the basis for your first property. And that's the quotient of powers property. Take a moment to copy that down. Let's do a few examples. First example. Let's say I have 2 to the 7th over 2 squared. Since both of these powers have the same base, 2, it means we can subtract their exponents. 7 minus 2 gives us 2 to the 5th. Next example. Let's say I have 4 squared over 4 to the 5th. Well, both of these powers have the same base, 4, which means we can subtract their exponents. So 2 minus 5. Now 2 minus 5 gives us 4 to the negative 3. Now if we remember from the first day, we can't leave this answer as this because it has a negative exponent. So we have to simplify it. So remember, this guy can ride the elevator from the numerator down to the denominator. So what we end up with is 1 over 4 to the 3rd. Next example. Let's say I have x to the 4th over x to the 4th. Well, x to the 4th over x to the 4th gives us x to the 0th power, which, remember, we can't leave that as the way it is either because it has a 0 for an exponent. So x to the 0th power gives us 1. Last example, a little bit more challenging. Let's say we have d to the 4th, e to the 3rd, all over the quantity, the product, dE, to the 2nd power. Now, before we can begin to use our quotient of powers property, in other words, before we can begin to use that division sign, we've got to make sure that the numerator and the denominator are both simplified. Well, the numerator is. It's ready to go. But the denominator has a product, a power of a product. So that means that the d and the e are both to the 2nd power. From that point, now we can begin to use our quotient of powers. The d's, well, you got 4 minus 2 gives you d squared. As you look at your e's, you got 3 minus 2 gives you e. D squared e is a simplified answer. Take a moment to go to your homework practice sheet and try the first 3 problems. Okay. Once you finish those problems, you can listen to the other YouTube video to get some feedback on how you did. Okay. Go to the, flip to the next page, or turn to the next page in your Exponent notebook, and consider this example. Let's start with a fraction, a quotient, if you will. Let's say you got 2/3, and you want to take that quotient to the 3rd power. So what that means is you're going to multiply that 2/3 times itself 3 times. Well, recall as how you multiply fractions, you just multiply right across. So all the 2's multiply times one another, and all the 3's multiply times one another. So what you end up with is 2 times itself 3 times, or 2 to the third. And on the bottom, you end up with 3 times itself 3 times, or 3 to the third. Since the 2 and the 3 are not the same base, this is simplified. This leads us to the property, the positive power of a quotient property. Take a moment to copy that down. Let's do some examples. Okay, let's say I have a quotient 4/7, and I want to square that. Well, both the 4 and the 7 are both going to get squared. So you end up with 4 squared over 7 squared. Simplified. Second example. 3d squared over EF. This is going to be all to the 4th power. Now, as you're beginning this problem, remember to obey the order of operations. And think about what's inside the parentheses first. Now, if there's anything inside there that can be simplified, then go ahead and do so. But as you look inside there, there's nothing there that can be simplified. So then we go ahead and resort to the exponent. That means every piece that's inside that parentheses, the 3, the d squared, the e, the f, everything goes to the 4th power. So 3 to the 4th, well, d squared to the 4th gives us d to the 8th. E to the 4th, f to the 4th. Simplified expression. Okay, last example. Let's say I have 2x to the 3rd all over the product xy to the 3rd, and all that quantity is squared. Okay? Well, remember what I said about the last problem. Take a moment to look inside those parentheses and see if there's anything there that can be simplified, maybe crossed out, before we eventually do that square on the outside. Okay, so as we look inside the parentheses, the numerator at the top is already simplified. But the bottom, that product that has a power, so both the x and the y go to the 3rd power. Now you can see that there's something inside those parentheses that can be crossed out. You have x to the 3rd on the top and x to the 3rd on the bottom. That just ends up crossing out to be 1. Therefore, that parentheses becomes much more simplified before we had to use a square. Now, final little step here. The 2 becomes squared. The y to the 3rd becomes squared, and we get y to the 6th. Simplification. Take a moment now, go to your homework practice sheet, work problems 4 through 6. Remember, to get a little bit of feedback, watch the other YouTube video of me working those problems. Okay. Let's do another example here. Okay. Consider this. Let's say we start with another fraction. And let's say here we take this to a negative exponent. Well, we're still going to follow the same example as we did before. We're still going to take the 2 to the negative 2 power and the 5 to the negative 2 power. But remember, we can't leave the answer that way because you still have a negative exponent. So what that means is that both of them get to ride the elevator. The 2 goes on the bottom, and the 5 is going to end up on top. And when they do, of course, their tickets get taken. You end up with 5 squared over 2 squared. That is simplified. What we've basically just done there is the negative power of a quotient property. Take a moment to copy that down. Let's do a couple of examples here. Okay, first one. Let's say we have 3/4 to the negative 3rd power. Well, both the 3 and the 4 here are going to be taken to that negative 3rd power. But before we box it up, we have to realize that they both have negative exponents, which means they're going to ride the elevator. The 4 comes up to the top, the 3 goes down to the bottom. Since both the 4 and the 3 are different bases, we are set, and we are simplified. Next example. Let's say I have the fraction 2x squared over y to the 3rd, and that quotient is going to be taken to the negative 2nd power. Okay, well, Just like the problems above it on the other property, I'm going to look inside those parentheses and see if there's anything there that I can go ahead and simplify before I take it to the negative second power. Well, there's nothing there. So that means that every piece, the 2, the x squared, and the y are all going to go to the negative second power. It also means that every single one of those pieces are going to get to ride the elevator. The 2 goes down to the bottom, the x goes down to the bottom, and the y ends up going on top. Okay. Last example. Let's try this guy. Let's try m over n to the negative second power times 6n over 2m to the negative third power. Well, here we have a multiplication in the middle. We have exponents. And we also have parentheses. So it means we've got to do the parentheses first, then the exponents, then the multiplication. Okay, so as we look at those parentheses, the first parentheses has m over n, which means it's already simplified, so we're not going to do anything there. But the second parentheses does have something that can be simplified, namely the 6 over 2. That just becomes 3 over 1, or 3. So I can go ahead and rewrite this. As such. Then I can begin to work the exponents. So in the first example, the m goes to the negative 2 power. So does the n. And the second parentheses, the 3 goes to negative 3, the n, and the m. Then you'll notice here, since we're multiplying these two fractions, well, you just multiply the tops together and multiply the bottoms together. It's just one big giant fraction. So what that means is that we can write this as one fraction, and I can take all those negative exponents and let them go ahead and ride the elevator. Okay, so we've got m squared on bottom, 3 to the third on bottom, n to the third on bottom, n squared on top, and n to the third on top. Now before I box it up and say I'm done, I got to look at one last time here at my quotient of powers property and see what of these things can begin to cancel out. Well, the n squared and the n to the third cancel out, give me n to the 1. The m squared and the n to the third cancel out, give me m to the 1. And then, of course, the 3 has nothing to cancel out with. So what I end up with is m to the first on top, 3 to the third on the bottom, times n. That expression is now simplified. That's absolutely as hard as it's going to get. Okay? Please make sure you have the practice problems attempted and bring those to class along with your exponent notebook. I look forward to seeing you tomorrow. Thank you.